Hello, everybody. We are going to be starting to learn about stoichiometry, the thing we've been thinking about for a while but haven't really talked about. Okay, stoichiometry, first of all, is the study of quantitative relationships between amounts of reactants and products in a chemical reaction. Sounds dull, boring. It's actually really easy. Not difficult. The word makes it sound difficult, but it's not. It depends upon the law of conservation of matter that tells us that every atom going into a chemical equation must also be present in the product. Nothing magically appears or disappears. And we're going to use that fact to our advantage. All right, so I want you to look at this balanced equation. I highlighted the word balanced because we can't begin any stoichiometry without balancing the equation. Again, we have to obey the law of conservation of matter. So if your equation isn't balanced, the equation would reflect that you're not obeying the law of conservation of matter. All right, now ways of looking at this particular balanced equation. The first thing we learned is how to interpret the coefficients in terms of particles. For example, 4Fe can mean 4 atoms of Fe. 3O2 can mean 3 molecules of O2, and 2Fe2O3 can mean 2 formula units of iron 3 oxide. Okay, we later learned that we can also interpret these coefficients in terms of moles. So we see we can look at 2 moles of iron, 3 moles of oxygen, and 2 moles of iron 3 oxide. Okay, and once we know how many moles that represents, we can use the molar mass to convert these into masses. And we can confirm that the masses of iron and oxygen combine to form the masses of our iron 3 oxide. Okay, so 223.4 plus 96 is going to equal 319.4. All right, wonderful. So what do we do with that? All right, well, the key to stoichiometry lies in the mole ratio. The mole ratio is the pivot point around which all of our stoichiometry, or we say stoic problems, revolves. Okay, so our mole ratio is the ratio between the moles of any two substances in a balanced equation. Could be two different products, could be a product and a reactant, two different reactants. A reactant and a product, there we go, that's a little bit better. Could be any two. And of course, this is an equation that has 2 reactants and 1 product, and we know that there are lots of variations that are possible. So let's take a look at the first two. We have 2 moles of aluminum and 3 moles of bromine. Those are represented in the first and second mole ratio, 2 moles of aluminum over 3 moles of bromine. Or we can flip this and put the 3 moles of bromine on top and the 2 moles of aluminum on the bottom. We could take this and this. We could take our aluminum and our aluminum bromide, and we could say 2 moles of aluminum over 2 moles of aluminum bromide, or flip it and put 2 moles of aluminum bromide over 2 moles of aluminum. The last possible combination is our bromine and our aluminum bromide. We could say 3 moles of bromine over 2 moles of aluminum bromide. Or we could flip that and put 2 moles of aluminum bromide over 3 moles of bromine. Okay, so for an equation that has 3 constituents in it, you're going to be able to make 6 possible mole ratios. And of course, that number will change depending on how many possible combinations can be made. So why do we even care about this? Well, first of all, and maybe I should have put this first, stoichiometry is a fundamental skill in chemistry. You cannot go further in chemistry without learning how to do stoichiometric calculations. The good thing is they're actually quite easy once we get the hang of it. What it does is we combine what we've already learned about mole mass particle conversions, and then we add this mole ratio, and now we've got the power to do a huge amount of different kinds of equations. We could start asking questions like, if all I have is 2 grams of aluminum, how many grams of aluminum bromide could I possibly make? Well, we need both of these things to do that, and we'll put them together. All right, for now, I have a homework assignment for you. And there's 3 questions, very simple. For the first question, I want you to write all the possible mole ratios for these 3 balanced equations. Okay, for the second question, I'd like you to just balance the equation. You haven't done it for a minute, and it's important to practice. And for the third one, I would like you to take these written equations and turn them into balanced chemical equations, and then also determine all the possible mole ratios. Now, these particular 2 have things like hydrogen and oxygen in them. You need to remember your diatomic elements, or the magic 7. I used the term Brinkelhoff because it helps me, and I also said we could remember them using the mnemonic, have no fear of ice cold beer. Okay, so remember, anytime we see oxygen in a chemical equation, it's going to be present as the molecule O2. Anytime we see hydrogen in a chemical equation, it's going to be present as the molecule H2. And that's going to be critical in balancing your equation. Okay, I look forward to seeing your homework. Thank you very much, and have a wonderful day.